I wouldn't say garbage collection is one of my favorite topics, but I don't think it hurts to talk about it a little bit. It's pretty straightforward. It's actually very involved if you want it to be. There's plenty of writing out there as far as garbage collection algorithms go and that sort of thing. And I don't know everything there is to know about .NET's garbage collection simply because it works, and I kind of don't care at that point. And sorry, it's just one of those things I don't get passionate about. Here's our stack. Here's our heap. Let me come over here and make a class. I'll call it int wrapper. And the only reason I'm making an int wrapper is to wrap an int, public int, wrapped int. And since this is a class, it'll go out on the heap when I instantiate it with new. I could also accomplish this with boxing. However, I want to do it with a class. Let's go down here. Var wrapped1 gets new int wrapper, like so. Let me scroll out a little bit. Control L, Control V, V, wrapped2 and wrapped3. Let's change wrapped1's dot wrapped int to a 1. Control L, Control V. Change this to a 2, 3, and 2 and 3. So you can see each individual object, their wrapped int will be assigned to the corresponding value. Now let's actually execute this. F10. What's going to happen as far as our stack and our heap is concerned? Do you remember from several previous videos? Okay, we have wrapped1. That is a reference that we've defined inside of the scope of a method here. So I'll say this is wrapped1. I need a thinner font here. Let's try this again. We'll do wrapped1 right here. That's not thinner. Come on. Thinner. I probably didn't click it, huh? Wrapped1. Alright? And it's going to reference this object created by new here. Now, heap algorithms, the new operator, it's responsible for going out to the heap and finding a place to put an int wrapper, which in this case requires 4 bytes, but then we've seen in previous videos we need an extra 8 bytes, so 16 bytes total. Anyway, new is responsible for going to the heap and finding that room, and then allowing us to put the object there. Well, new just doesn't kind of randomly pick whatever room there is. What it likes to do is keep this as nice and tight and organized as possible. So I'm going to take our int wrapper and instantiate it right here, like so. And so that's hopefully neater than just kind of randomly putting it out here like I do in most of my drawings. All right, F10. That state is now set up. Wrapped2, I should actually put the value here. Remember, the default values are 0. The new again has to go out to the heap. Oh, is there room for another int wrapper? There is. It would make sense to put it right here, right next to the other one, so we don't clutter up our heap too much. So this will be wrapped2. Put the default 0 there, and the reference wrapped2 is residing on the stack. And there we go. We're referencing that object. Very good. F10. Wrap3 again. Same idea. New has to come out here. I'll put wrap3 right here. Looks good. So on and so forth. Wrapped3. Reference that. Very nice. And then, 1, 2, 3. So here we go. 1 and 2 right here. Like so. And then 3. Hopefully this isn't too boring. Now I want to change this up a little bit. Watch what I'm going to do. I'm going to come in here. We'll hit Shift F5 to stop the debugger, get rid of our yellow line. And then I'm going to come, actually before we even need to run this, well, we'll do that a little bit later. I'm gonna come put a gc.collect here, which is me telling the garbage collector, hey, if there's any trash out on the heap here, please go collect it. Right? And the garbage collector is actually, it's a background thread, constantly in the background. It's kind of a low priority sleepy thread, and it'll wake up and collect when we need it to. We don't need to explicitly tell it to, but this is nice. I can say, hey, go clean up right now. And in fact, if we hover over that, forces an immediate garbage collection of all generations. That's another garbage collection thing, generations, but I'm not really into that, like I already said. Go collect. Well, is there any trash out here that needs to be collected? Okay, there probably could be from other things happening before we got into main, but maybe .NET set up some objects and that sort of thing. But as far as our objects go, no. Okay, we have a valid reference to wrap 3, a valid reference for wrap 2, and a valid reference for wrap 1. So all these are legitimate objects, nothing to collect there. Right? But then what if I come here and say, hey, wrap 2, you get null. Alright, let me grab my eraser here. Wrap 2 gets null. You're no longer referencing your buddy out on the heap. Okay, well this object's like, I've been abandoned. Well, yeah, it happens. Okay, and then I come in here and I say, hey, gc.collect. Well, now this object is up to be collected. Okay, it's no longer needed. So the garbage collector, and it kind of does this in stages, but you can go read about it online if you want to. But essentially, it's going to come here and mark this object and say, hey, you're done, you're out, thank you, I need this room again. But then the garbage collector sees, hey, there's this gap here. And at that point, it starts to compact the heap. Meaning, what if I wanted to put an extremely large object on the heap? Say the object would take up all of this room right here. It would need all of this and this room right here as well. Okay, is there enough room to put this extremely large object in memory? Well, yes, there is. The problem is, if we put it in like we've done here, it's going to chew up part of 3. But if I took this 3 and defragmented this heap, compacted it, brought this 3 down, then all of a sudden I'd have room for this big green object. So let's just do that. I'm going to take 3 and give up that room for that really large green object, that big green monster, and we'll compact 3 down to here, like that. There you go. And then, I need to update all references to this object. We have wrap 3 here. So the garbage collector, this is kind of part of why we call it managed code, because the garbage collector is changing your references without letting you know. But you don't care. As long as our reference is always legit, we're totally fine with that. So there you go. That's why the garbage collector will compact data. Now, I'm not going to do too much on garbage collection in my videos. I'm sorry about that. If it really fascinates you, there's plenty of reading. I want to actually prove to you that this is how this is going to go down, though. Let me take that off the screen. And you can stop the video now if you're happy. Otherwise, hang on. I'm going to bring up the memory windows and debugging here. So let me control. I've actually started to learn the hotkeys for this. Control DY for the first memory window, and then Control DR for the registers. Let's instantiate wrapped 1. I know EAX has an address close to wrapped 1, so I'll copy the value out of the EAX register, paste it here, and here, as we've seen in other videos, here is our wrapped 1 object. I'm going to do red right here. Okay, here's the type pointer and the sync block index, and then here's the wrapped in. Now watch what happens. I'm going to F10, and you'll see wrapped 2, just like I drew in the drawing I took off the screen. I think we're done with these registers. Wrap 2. Hey, look at that. There's wrap 2. We'll do that in green. Okay, here's wrap 2. Like so. And then wrap 3. Oh, there we go. There we go. Look at this heap. It looks like a stack, doesn't it? But it's not a stack. It's a heap, meaning we can put objects really wherever we want to and pull them out and that sort of thing. My son told me, I don't know how he thought this up. 10 years... Well, more than 10 years programming for me, and I'd never heard of this before. My son came up with it. He says, "Of course, a stack is a LIFO structure, Daddy. If you pull the value out of the middle of it, it would all come crashing down, and then you would have a heap." Does that make sense? You'd have a heap of stuff. Jenga. You ever played Jenga? Anyway, all right. Watch these values here. Okay, this is wrapped 1's int, and wrapped 2's int, and wrapped 3's int. So we will see 1, 2, 3. So F10, there's our 1. F10, there's our 2. F10, here's our 3. Now I'm going to say GC collect. I want you to pay attention to this. Is anything going to change? F10, no, we saw that another object was moved here, but no, our data is legit. That's good. Now we're going to abandon wrapped 2. Notice how I did red, green, blue. Okay, wrapped 1, wrapped 2, wrapped 3, red, green, blue. We're going to abandon our green one here in the middle. Okay, wrapped 2 gets null. Nothing changes out here. And then I'm going to say GC collect. Well, Bye-bye. Okay, pay attention to what happens. F10. Look at that. Look at that. We still have wrap 1 and wrap 2, but then the garbage collector saw there was a little bit of room here and shoved something in there. So that's kind of cool, right? Anyway, garbage collection in a brief nutshell. Again, there's plenty of reading out there if you want to read about it and really learn these algorithms inside and out.